lower down to 80.
Excellent. Looking forward to rain. All right, so let's pick up where we left off in 5.6. We had just talked about the formulas for derivatives, so let's just look at those real quick before we move on. These are the ones that we wrote down last time. So these are the derivatives of the different inverse trig functions, the arc functions. And there's some similarities, of course, as you go through. I'm not going to expect you to memorize these. You'll probably sort of get comfortable with them. Yes?
Did you say we get to use our derivative sheet on our test?
Yes. If you haven't already done so, it would be a great idea for you to go out and print off the review for the test. We'll talk about it on Tuesday, so if you have it by then, that's great. But you get to use a clean sheet of your derivatives and your derivatives sheets that I gave you at the very first day or whatever that are front and back. So as long as there's not any example problems on there or anything like that, it's just the formulas basically, then you can use that on your test. Yes?
5.6 and 5.7, will those still need to be done by Tuesday?
Yes, we will finish 5.6 and 5.7 today, and so then the homework for those should be done by Tuesday. Yes. And I'll have time that you guys can ask a few questions on that in class. Don't come and expect me to do the whole assignment, but I will have some time where we don't normally have time for us to ask a few questions over that. So if I do collect it and you have one question, it'd probably be fine to not come see me in my office. But if you have more than one or two, probably you need to. Okay? Yeah. Okay, so these are the inverse trig derivatives, and we're going to apply them. So first question is, we want to find the derivative of the arc sine of t squared. All right, so this wasn't on your skills test, but there was something that was kind of similar to this idea. And when you're taking a look at this, though they're not there, there's an understood set of parentheses here, correct? We understand that that's sort of an inside function to whatever's going on the outside. So we do actually have a chain rule here going on. Make sense? All right, so we're going to start with that that derivatives on the very first one for arc sine. So the arc sine is 1 over the square root, so that's where we'll start. So we've got our derivative, and it's 1 over the square root of what? 1 minus, and the original formula says what? X squared. But what is our quote-unquote x in this problem? T squared. So this is not going to have an x, and it's going to have a t, and it's actually going to have t to what power? The fourth, right, because I should have t squared, and then that would be squared because of the formula. Sound good? Okay, am I done? No, what do I still need? I need the dx. I need the derivative of what's inside, right? So what's inside of this function? That t squared, right? So what is the derivative of that? 2t. And while it's very minor, there is one little thing we can do to simplify, and what would that be? Yeah, I can put the 2t on top. So far, so good? Okay, so that one was a pretty straightforward one. We just had a little bit of a chain rule going on. Next one has a little bit more going on. It has that natural log stuff, which we've done before, so that's a piece of it that's sort of from before. And then I've got a piece of it that's about arc tangents, and you'll see they're being combined in this particular problem to give a function in a moment. But let's get started. Let's remind ourselves, what is the derivative of a natural log? 1 over x, whatever is inside of the function. And what's inside of this particular function?
T squared plus 4.
T squared plus 4. Am I done with that one? Nope. What do I still need? The derivative of the inside, the t squared plus 4, which is 2t. All right, very nice. Now I have minus the 1/2, and I need to do a derivative of arctangent. So let's go back here and take a look. Arctangent's the third one down. Arctangent is 1 over 1 plus x squared. Okay, so similar. They're all very similar, these formulas, but 1 over 1 plus x squared. So I'm going to have 1 over 1 plus what? T over 2 quantity squared. Very good. And then I need the derivative of the t over 2. What is the derivative of t over 2? 1/2. Okay, so that's the derivative. That's the calculus. Everything else is algebra. We get to do lots of algebra now, right? All right, so the first piece of algebra, pretty straightforward. Just like the last problem, we're going to put the 2t on top, and the t squared plus 4 is still on bottom. The next piece right here, and I'll do it kind of one piece at a time, we're going to combine the 1/2s, which will give me 1/4. And I'm going to also simplify this fraction over here to say that I've got t squared over 4. All good? Okay, what's one more thing I can do then? Yeah, I could distribute the 1/4 through. And actually, it's really just distributing the 4 on the bottom, right? The top doesn't change, so I've got 1 over. But what does the bottom become? 4 plus t squared. And look at the wonderful thing that you now see. Those denominators happen to match on this one, don't they? Now, those particular problems originally did not look anything alike, but their derivatives have the same denominator, so I can actually combine them. In fact, I don't even need a common denominator like to get one. I actually have it exactly the same. So that's very friendly. So my last step will be to simply combine those as 2t minus 1 over, either write it as t squared plus 4 or 4 plus t squared. Any questions on that one? Okay, let's try the last one then. The last one has an arc sine in it. We already encountered that one on part A. So we know that this should be y prime equals 8, and then what? Okay, 8 over the square root of 1 minus, and it would typically, the formula itself says x squared, but my x in this problem is actually x over 4. So I have x over 4 quantity squared. Look good? All right. The next problem, I'm going to rewrite it as though it's just a 1/2 and ignore that for the moment. I have x times the square root of 16 minus x squared. What do I need, derivatives-wise, to do in order to make this problem work? What am I really working with here? This is really a product, right? It's really a product, and I'm going to need more space because products take a little bit of space, don't they? And it might be helpful to remind ourselves that we can think about this as 16 minus x squared to the 1/2, right? Most of you had problems like that on your derivatives skills quiz last time, and most of you did things like this. All right, so what am I going to do first? This 1/2 applies to everything, but what am I going to do first? Okay, so I'm going to write my x down, and then Erin, you want the derivative of that piece right there. So can you tell me what that's going to be? You do the chain rule, yeah. Good, and don't forget the negative. Very good. Okay, that was the hard one, right? The other piece's derivative is easy, but I think I still am going to be out of space. Let me scoot this over just a bit more. All right, the other one's going to be then plus what? Yeah, just the 16 minus x squared to the 1/2, because the derivative of x is 1. I don't know about you, I look at this and I think, is there any hope to combine anything? And there is, but it looks really messy right now, doesn't it? I mean, what a mess. All right, so let's see what we can combine. The first piece over here, I've got 8 over the square root of 1 minus x squared over 16. And we'll work with this a little bit more in a moment to clean that up, because I've got a fraction within a fraction going on, and we're not going to leave it that way. But let's come back to that in a minute. Let's take a look at what's over here. I've got this 1/2. This 2 and this 2, those can reduce, right? And then I can combine the other two x's to give me x squared, and it's negative because the negative 2x. So this is actually negative x squared. And then that negative exponent is actually just a denominator waiting to happen, right? And the 1/2 can be a square root again, so that I can hopefully see if maybe something will combine later. So now I've got 16 minus x squared underneath the square root of the denominator. And then the other piece is a 16 minus x squared underneath the radical, but just standalone or as a numerator. Okay, so those two radicals that I've got right now, at least in red, those match. They're not in the same location, but they do match. I'd like to see if I can get this one to match it, and I think I can. What would I need to do to that very first radical in the denominator to get it to match the other two radicals? Multiply by a 16 underneath the radical, right? Okay, so what I really want to do is I multiply by a square root of 16, because in order for it to be underneath the radical, I have to also have the 16 underneath the radical, which would also then happen to be on top. But what is the square root of 16? It's actually 4, so I really am only multiplying by 4, so this numerator is a 32. Does everybody understand that? Okay, because it's an easy thing to sort of overlook and think that I'm really multiplying by 16. I'm really not. I'm multiplying by the square root of 16. And then my denominator will be the 16 minus x squared that the other one already is. All good so far? So that cleans up pretty nicely. This other piece over here, I need a common denominator between the whole thing. I've already got 2 of these pieces to have common denominators. I've also got this 1/2 thing going on. So let me distribute the 1/2 through just for fun right now. So this first one will be plus. I've got the x squared on top, and I've got the 2 on bottom, and then I've got a square root of 16 minus x squared. That's the piece that's, the way I want it to be already. I've got the negative 1 over here, and I'm going to have that 1/2 in the denominator, or that 2 in the denominator from the 1/2. I need them to have the same denominator, though, which means what I really want is I really want to treat this like it's a fraction that is going to be multiplied by the denominator I want, namely the square root of 16 minus x squared. What nice thing happens on top when I do that multiplication? The square root reduces or cancels or goes away. I'm hearing all those phrases. So I really just have the 16 minus x squared on top, right? Because when I multiply something by itself as a square root, it actually has the elimination of the square root. But the denominator is exactly then what I want, which is 16 minus x squared. What is the only thing missing from being able to combine these 3 fractions now?
2 on that side.
The 2 on the very first one. So I can take this and put a 2 here, and I can make the 32 a 64. And then I could actually combine them, right? All right, let me move this to a new slide. Okay, so this is where we are. Okay, so I can put all of these together now. I've got y prime equals, I have a 64 plus an x squared minus a 16 and plus an x squared. Right, this negative right here has to be distributed through. And then I have a 2 in the denominator, and I have a square root of 16 minus x squared in the denominator. So what will I get on top when I combine like terms? Good, 2x squared. And then what? Plus 48. Anything else I can do? Yeah. Everything has a 2 in it, so I can take this 2, and that 48 will become a 24. So my final solution to this problem is x squared plus 24 over the square root of 16 minus x squared. And remember, we don't rationalize that because depending on what the variable is what depends on whether or not it's actually irrational. It's not irrational in its current form, okay?
What if we took the derivative of 8 arc sine x to the 4th? Why didn't we take the derivative of x to the 4th?
We missed it, didn't we? Oh, let's go back and fix that. I wasn't watching my notes either. Okay, thank you, Taylor. That's okay. You know what? It's all right. We're going to fix it. This happens all the time on you guys' homework, right? Mm-hmm. You realize after the fact, oh, shoot, I missed something. All right, so you just don't say anything. You just pretend like it didn't happen.
I put it down, I just didn't say anything.
Oh, you put it down. You just didn't tell me, huh? Oh, okay. All right, well, let's go through here and fix my 1/4 issue. That's actually a pretty nice issue to fix because if I had actually had that fourth there, wouldn't I already have the square root 16 I need? I would. Oh, dear. So it's really not going to fix or change a lot. It's going to change this 16 right here. I'm not going to have to actually change that numerator at all. Look at that. I just erased it. You can erase it just like that, too. You've still got an 8 up there, right? Because that 4 right here is actually the square root of 16. And so, I do need to change it right here, though, because I doubled this number right here. So it will be a 16 at this point because I doubled the denominator, right? Did I make another mistake?
No, I'm just confused how you got the 4 to become the square root 16.
Because 4 and square root 16 are the same thing.
Okay.
I want a 16 to multiply underneath the radical, and that has to be a square root because it's already got a square root on it, and 4 and square root of 16 are actually the same value.
On top, since
Right.
the 4s aren't.
Because the 4 should have already been there. Exactly. Okay, are we good at this point where I've got my 16 and my 2? My last line of this now. Okay, so over here, that's a 16. This one, oops, is a 16. Oh, it's going to simplify even better. Look at that. What happened here? Yeah, I don't have it plus anything on top. Well, that mistake was easy to erase, wasn't it? I know some of you are still erasing, but another good reason to do math in pencil. Thank you, Taylor. Did we get it all fixed? I think we got all the pieces to clean up now. Maybe I should check to see if my notes actually say this. Oh, lo and behold, they do. That's good news. Okay. Any questions on this one? Okay, great.